Hello everyone, my name is Mehmet Efe Özenç. I'm a student in the Industrial Engineering department at Bilkent University, and today I will be presenting my Physics 101 laboratory experiment on the asymmetric centripetal force system. This experiment focuses on understanding how rotational equilibrium is achieved when two unequal masses are connected by a string through a central hole and rotated on a turntable. And now I will explain the theory behind the experiment. In a rotating system, two masses are connected by a single string that passes through the center of the turntable. Because it is one continuous string, the tension acting on the both masses must be exactly the same. Each mass experiences this tension while rotating, and the system reaches equilibrium when the inward pull on both masses balances. Since both masses rotate with the same angular velocity, the system adjusts itself so that the product of mass and radius is equal on both sides. This balance conditions is the fundamental relationships we test in the experiment. For the first trial, I started by selecting the 50 gram and 100 gram masses. After attaching them to the string, I set the system into rotation and waited until the masses reached a stable equilibrium position. Once the masses stopped moving inward or outward, I measured their radii and recorded the values of 15.1 cm for 50 gram mass and 7.8 cm for the 100 gram mass. For the second trial, I repeated the setup using the 50 gram and 120 gram masses. Once the system began rotating smoothly and reached equilibrium, I measured the new radii. In this trial, the 50 gram mass stabilized at 15.2 cm and the 120 gram mass stabilized at 6.3 cm. Again, the heavier mass moved inward while the lighter was shifted outward, consistent with the balance condition the system. For the final trial, I used 120 gram and 60 gram masses and followed the same rotation procedure. After the masses reached a steady equilibrium position, I measured their radii. The 120 gram mass settled at 6.4 cm and the 60 gram mass settled at 13.1 cm. As in the previous trials, the heavier mass stayed closer to the center, while the lighter mass remained further out, matching the expectation theoretical behavior. And now I am demonstrating the graphics of the experiment. Of course, some sources of error were unavoidable. The absolute 0.1 cm ruler resolution created uncertainty in radius measurements, and heavier masses produced larger uncertainty values, such as 0.012 in the trial 2. Small friction at the center hole, slight wobbling of the turntable, and human reading error also contributed to deviation. Despite these factors, the percentage error remained low, showing that the experiment was carried out with good precision and that the results strongly supported the theoretical method. Here are the error codes. In conclusion, this experiment successfully demonstrated how mass distribution affects the rotational equilibrium and how angular momentum constrains the behavior of the system in circular motion. It also highlighted the importance of accurate measurement and the relationship between theoretical physics and real-world observation. Thank you for listening.